Hello everyone. Welcome to the video lecture series of probability. I am Professor Mayur Gohil. In this video lecture, I shall be dealing with the question that you see on your screen. Now, the question says that we are given a distribution function of a random variable x, which is capital F of x equals to 1 minus c times e to the power minus 2x, and x is greater equals to 0. We are asked to find the value of c, the PDF, and the probabilities which are given over certain interval. Now let us handle this question and understand how to solve such kind of questions. Now the first important thing to understand here, that we are given the continuous random variable. How do we come to know about that it is a continuous random variable? It is out of due to the interval. So here here x is a continuous random variable, and its distribution function its distribution function that you see. Now this distribution function is CDF. Okay, please remember it is the cumulative distribution function. So CDF, or cumulative density function if you want to call it, is that, okay, is f of x equals to 1 minus c e raised to minus 2x, where x is greater equal 0. Now CDF is always denoted with capital F. This is first thing that one must remember. CDF is always denoted by capital F letter. Okay, that is how it is denoted. Now, how do we find the PDF from a CDF? That is one question. So let us use a property here. So we write here that we know that the PDF, okay, the here we'll write here that f of x, small f of x, is the derivative of capital F of x. Okay, it is the derivative of capital F. So if we do the derivative here, d by dx of 1 minus c times e raised to minus 2x, when we do the derivative we get here it is 2c into e raised to minus 2x. Okay, this is the derivative we get. Now again we use the property to find the value of c now. Okay, so here, having said what is the PDF, so here integration of minus infinity to infinity f of x, small f, okay, that's going to be equal to 1. Therefore minus infinity, yeah, so but the interval is from 0. Okay, so 0 to infinity, 2 times c into e raised to minus 2x dx is 1. Alright, so we further integrate this. So what happens is 2c comes outside the integration sign, and we have 0 to infinity e raised to minus 2x dx equals to 1. So when we simplify this, we get 2c into e raised to minus 2x from yeah, divided by minus 2, and from 0 to infinity we get, and this is going to be 2c. Alright, that minus 2 is outside, and here when you integrate is e raised to anything to the power infinity, minus of infinity rather, that's gonna be 0, and here it's minus sign and it's 1 is 1. So what do we get is minus c into minus of 1 is 1, so c value is 1. This is the value of c. So we now write the required PDF. Therefore, required PDF is, you can write in this manner. So that will be, we have already calculated that, right? 2 into c was the value, so c we will put 1 here, and e raised to minus 2x, and x is greater equal 0 and 0 otherwise. That is what is there. And then required CDF is capital F of x is equals to 1 minus, we'll write down the CDF here, so 1 minus e raised to minus 2x, where x is greater equal 0, and when x is less than 0, here you will have 0. Okay, so that's how the CDF is here. Oh, x is less than 0, negative. Here it would be x less than 0. Yeah, that's how we can take the PDF and the CDF. Now, having said that we know what is the CDF and what is a PDF, let us calculate the probability that is asked. So the C portion says that we are asked to find the probability of x greater equal to 2. Alright, now how do we do this? So first let us draw the interval. Now as we see that the probability value of x or the PDF is defined from 0 onwards. Okay, so 0 to infinity is the major interval in which we are considering it, and here at this somewhere at this place there is somewhere 2. So from in order to find the value of the probability on this interval, we know that the probability of for 0 to infinity is 1. Okay, so it is as good as saying from we take the full probability and subtract this portion of the probability, then we will be able to get the answer. Okay, so what we can do here is probability of x greater equal to 2 is same as 1 minus probability of 0 less than x less than or equal to 2, or even if you include them, it's not a problem. So when we take this probability, now there is a property that will be useful. Okay, so I'll write down the result over here which is useful. Yeah, let me write down the result. The result is like this, that result says when you have a probability of a less equal x less equals b, okay, over a particular interval, whether it is inclusive, the intervals are closed or open-ended, not an issue. Only thing, there should be finite limits. Then this probability is as good as capital F of x, that is CDF value at b minus the CDF value at a. So using this result, I can write that this is same as 1 minus the CDF value at 2 minus the CDF value at 0. That will be your answer for the probability, and let us calculate this. So therefore probability of x greater equal to is same as 1 minus the value of probability at 2. Okay, so in the CDF at 2, so it is 1 minus e raised to minus of 4 minus times 1 minus e raised to minus of 0. Okay, that's our probability, and here it is 1 minus e raised to minus 4 plus yeah, sorry, here it's gonna be minus 1 and then plus of 1. Okay, so final answer of this is going to be, all this gets cancelled, and when you supply this inside, the minus sign inside, it is 1 minus 1 plus e raised to minus 4. So your final answer of probability will be probability x greater than 2 is e raised to minus 4. Okay, and the value of e raised to minus 4 will be 0.01831. Okay, that's the value of the probability. Now let us see the next part. The next question here is we have to find the value of probability between 2 and 4. So let us see how to handle this again. It's in a very similar manner we can do. That is, the yeah, the D portion is between 2 and 4. Now whether the interval is included or not a big issue here. Alright, whether the interval is a closed interval or an open interval, it won't be a difficulty till the time the values are finite. Otherwise we need to handle it in a different way. But here this is as good as to say the probability evaluated at 4 minus the CDF, rather evaluated at 4 minus the CDF evaluated at 2. So it is 1 minus e raised to minus 8 minus yeah, it will be 1 minus e raised to minus of 4. So what will happen is we'll have here e raised to minus 4 minus e raised to minus 8, and so this will be, yeah, so the value of this probability, if you are allowed to use a calculator, then you can use a calculator and calculate and give the answer. So answer is 0.01798. That's okay, otherwise you can keep your answer the way you have got it. Okay, so and then last part on this is we are told to find the probability of minus 3 to 2. Okay, so this is again a nice boggling question a bit. So probability from minus 3 less yeah, x less 2, if you try to do, then you can use that logic that obviously that this is the value of probability, that you can use the logic that f of CDF evaluated 2 minus the CDF evaluated at minus 3. Now CDF evaluated at 2 is already 1 minus e raised to minus 4, and CDF evaluated at minus 3. Yeah, now this is a good question that we do not have the value there, so it's going to be 0 here. Okay, so when we are getting that kind of answer, we'll let us see how to handle that. And so because the CDF is not defined for the negative number in our situations here, so we will write here that it is going to be 0. So 1 minus of this, so it is 1 minus, so the value of probability is 0.98168. That will be your answer. I hope you like this video and you will benefit from this example. Um, I'll see you in the next video lecture. Please leave your feedback in the comment section below. It does help me to, it does motivate me to make new videos. Hit like and share it with your friends, those who find it useful. Thank you. I'll see you in the next video lecture with another problem and another topic on probability. Till then, keep solving good amount of mathematics. Thank you.